Hello, this is Susan Poss. I'm a math instructor at Spartanburg Community College, and today I'm going to talk with you again about complex numbers. We talked about adding and subtracting in a previous video. Today we're going to talk about multiplication and division. I have several examples here, but I'm only going to work just a few of these to give you a specific example of different types. And before I begin, I have something listed here on the right-hand side of the screen that I would like you to memorize. The basic imaginary component I, lowercase I, is equal to the square root of -1, which allows us then to have a definition so that we can take square roots of negative values. The one we're going to use in today's exercise is that I squared is equal to -1, so that one you will definitely see me use. And you have seen me use I to the fourth is equal to +1 in a previous video. So those again are things that you may want to just go ahead and memorize. All right, so on this first one over here on the upper right side of the screen, I want to use the distributive property. I'm going to take this imaginary component that sits out in front and distribute that over the parentheses. And this complex number in the parentheses has both the real part and the imaginary part. So as you see me multiplying, 3i times 2 is going to be 6i. And then positive 3i times -7i is -21. And this is I squared, because I times I is I to the second. Now, you can't stop at that point, because remember we have this piece here of I squared, and up at the top of the screen it says that I squared is equal to -1. So you're going to see me go one step further and replace this I squared with -1. So I'm just copying down the 6i, copying down the -21, and then replacing I squared with -1. And when I do the arithmetic, you'll see that I end up with a 6i plus 21. And since I like to put these in complex form, that is the real part first and the imaginary part second, I'm going to start out with the 21 and then write the 6i in the second position. So this is a complex number. Real part is first, imaginary part is second. So that was using the distributive property. Let me scroll down and we'll do another one with the distributive property. It's got a radical in it, which makes it a little bit more complicated to work with. So we're going to multiply again using the distributive property. So -I times the square root of 7 multiplied by 6 is generally you want to write the number first, the I in the middle, and then we will save the radical for the last position. So you see I'm just writing all of those different factors down, starting with the numeric coefficient first, the letter I, and then the square root of 7. So distributing into the second part of the parentheses, the -I times the square root of 7 times the +6 is going to give me -6 square root of 7, and then I times I is going to give me I squared. And just as we did on the previous one, I'm going to replace the I squared with -1. So let me just go ahead and insert that in a different color. Copy the rest of this down. And then in the last step, of course, you're going to see me doing a couple of things. When I multiply this -1 times this negative value, I'm going to get a positive value in that spot. And then again, just because of the convention of the way that we note complex numbers, we put the real part first and we put the imaginary part second. All right, so there are two examples using the distributive property. I wanted to show you a couple using FOIL, first, outer, inner, last. So I've got a binomial complex number 4 plus 5i and another complex number 4 minus 5i. So I'm going to do first times first, just like you did in your beginning algebra class. So 4 times 4 is 16. Then I'm going to perform the outer product, and I see a negative 20i there, and the inner product, which is a positive 20i, and then I'll do last times last, which is going to give me the negative 25i squared. So a couple of things are going on here. You'll notice that in the center, the two like terms, the positive 20i and the negative 20i, are going to add up to 0. So those two middle terms will drop out. I still have the 16, I still have the minus 25, and then again, in place of I squared, I always need to insert a replacement of negative 1 there. So this one works out kind of in an interesting way. We have a 16 here plus 25, which ends up being 41 if my arithmetic is right in my head. So something important that I wanted you to notice on this one, because we're going to use it in a minute when we talk about division, is that these two complex numbers are identical in terms of the number values, but they have the opposite sign. So one has a 4 plus 5i and the other has a 4 minus 5i. And these two are, you're going to hear me call them complex conjugates in a minute. And I'm going to be using that concept when I talk about division. And the important thing about that is that we start out with two complex numbers, we multiply them together, and we end up down here with something that's a real result, a real number result. All right, so that one's pretty straightforward. This next one's got some notation issues, so I thought I would take a minute to show you this. This is still first, outer, inner, last. So I'm going to do first times first to get 9. Then I'm going to do the outer product to get 3i times the square root of 2. Sorry, that's a positive there. I'm about to lose the sign. And here's a negative 3i square root of 2. And again, you can see that these are complex conjugates here. You see these two middle terms are going to add up to 0. And the reason I wanted to show you this one is to show you this last product. So I'm doing negative I times positive I, which is negative I squared. And then the square root of 2 times the square root of 2 is actually the square root of 4, which in just a minute you're going to see me simplify. All right, so let's get rid of these two. They add up to 0. So I have a 9, I have a negative I squared, and then I have a 2 here. And remember, the I squared has to be replaced with negative 1. So when I finish doing the arithmetic on this one, it looks like I have a 9 plus 2 equals 11. So again, when you multiply these complex conjugates here, same numbers, opposite signs, you end up with a real number result. So that's using FOIL. Let's go on down and talk about division of complex numbers. And of course, you see this is in fraction notation. And the way that you do a division problem is you put down a times mark, you put down a new fraction bar, and you look at this denominator, 9 minus 4i, and you come over into your new fraction and you use as the multiplier, notice all these parentheses I'm inserting here, you use the complex conjugate. So you don't change the sign of the 9, but you do change the sign of the imaginary part. But if you are working with a fraction and you want to keep equivalent fractions, then you have to multiply by the exact same quantity, both numerator and denominator, because in essence here you've multiplied by 1. So let me get everything enclosed in parentheses and start multiplying. So you see all these FOIL operations here. So first times first is going to give me 9 times 3 is 27. Then I'm going to do the outside product, positive 4i and times positive 3. I'm going to do the inside product, which is looks like negative 36i. I'm trying not to make any careless errors. And then the last times the last is going to be negative 4i times positive 4i, which looks like negative 16i squared. That's the top of the fraction. Now let me do the bottom. So 9 times 9 is 81. outside is positive 36i, and inside is negative 36i. And of course, that's why we did that, so those two things would add up to 0. And then last times last is negative 16i squared. Okay, so let's do a little bit of work here. We've already combined these two to 0 down here in the denominator. These two are going to combine, looks like, to negative 24i. And then I'm going to take this I squared and replace it with negative 1. And then I'm going to do a little bit of work in the denominator. I've got the 81. I can see that these two things added up to 0. Here's another negative 16i squared. So again, I squared gets replaced with negative 1. So now I'm just doing the arithmetic and the algebra of getting this all straightened out. So here's a 27 plus 16, and there's a minus 24i in the middle. I'm almost finished. And this is 81 plus 16. Let's see, what's 21 plus 16? I think that's 43. Let me get that off of that line so you can see it. And minus 24i, and you see me writing it again with the real part first and the imaginary part second. And I believe this is 97 on the bottom. Now, it's tempting to stop there, and generally that would be an acceptable form of the answer, but sometimes the instructions will ask you to put it in A plus BI form, or real part and imaginary part. So if you're asked to do that, you want to split out the 43 over 97 for the real part, and then the minus, and then the 24i over 97 for the real part. So always check your instructions. If it wants it in this A plus BI form, you want to split it up into two separate quantities. And if you start doing some of these on the calculator, you'll actually get these displayed for you in decimal notation. So don't let that throw you off if you start to see a bunch of decimal values when you're working on your calculator. All right, last one. Here's another division problem. How do you work a division problem? You put down a multiplications, you go for the complex conjugate, so same sign on the real part, opposite sign on the imaginary part. Let me put all this in parentheses. And whatever you do as a multiplier in the bottom, you have to match that as a multiplier in the numerator as well, because in essence here again you're multiplying by 1. Okay, so this is a distributive property which we talked about earlier. So negative 4i times 1 is negative 4i, and negative 4i times positive 3i is positive 12i squared. And this one should give me a real number in the bottom because I've deliberately chosen a multiplier that will do that. So there's first times first. The outside product is negative 3i from here. The inside product is positive 3i, and it's doing just what I expected it to do. And then last times last is negative 9i squared. Okay, so we're getting close. These two on the bottom, the positive and the negative 3i, will add up to 0. Let me go in and make those replacements for I squared. So everywhere you see an I squared, you're going to replace it with that negative 1 value. And it looks like on the top I have a negative 4i plus 12. And on the bottom I have a 1 plus 9. And so from here on out, it's just me kind of cleaning things up and getting it in the proper order. So I'm going to turn this around on the top because I want the real part appearing first and the imaginary part appearing second. Notice that the negative stays with the 4i. On the bottom, I get the number 10. Again, that's a good answer, but generally you want to take that and split it into a real part and an imaginary part. And of course here you can see that the real part reduces down to 6/5, and you would always want to do that. And the imaginary, the 4/10 is going to reduce down to 2/5, and don't lose the imaginary component. Again, you may see it written like that, or you may see it written with the 2/5, whoops, not 2/3, the 2/5 and the value I written out to the side. So all of those would be, both of these would be considered a correct version of the answer. So I think that's a good place to stop on working with multiplication and division of complex numbers.